Good morning, students. Today we have discussed about Laplace transform of periodic functions. So the Laplace function f is a periodic with period t. So f of t plus t can be written as f of t for all t's, where capital T is the smallest non-zero value for which f of t plus t equal to f of t. So for example, here we considered f of t equal to cos t. Cos t is periodic with the periods of n pi, where n is an even integer. For smallest period is 2 pi. So we have considered y is equal to f of t is period with period t. Applying Laplace transform equation, L of f of t can be written as integral of 0 to infinity f of t e power minus st dt. So then we have integral the sum. So sum of the two integrals is varied from 0 to infinity can be written as 0 to t plus t to infinity. So substituting split up the integrals 0 to infinity, the equation becomes integral of 0 to t f of t e power minus st dt plus integral of t to infinity f of t plus t e power minus st into dt. So next we have find the second integral by substituting u equal to t plus t, so that we have t equal to u minus t. So from these equations we have note that du equal to dt, where t is a constant. So integral in u has a lower bound of 0. So integral of 0 to infinity f of t e power minus st dt equal to integral of 0 to t f of t e power st into dt plus integral of 0 to infinity f of u e power minus s, substituting value of t equal to u minus t. So the equation becomes e power minus s u minus t into du. So observe that e power minus s u minus t equal to e power minus su e power minus st. So in these equations e power minus st, we can take it as outside because it is a constant term with respect to u. So the equation becomes integral of 0 to infinity f of t e power minus st into dt can be written as integral of 0 to t f of t e power minus st into dt plus, from here we have f of u into e power minus su minus e power st. From that term we can take it as e power minus st outside. So remaining terms is integral of 0 to infinity f of u e power minus su into du. So both integral 0 to infinity f of t e power minus st dt and integral 0 to infinity f of u e power minus su du are identical integrals. So since the variables of integration are dummy variables, so replacing the first and last integrals with L of f of t. So L of f of t can be written as integral of 0 to t f of t e power minus st into dt plus e power minus st. From the above equation, integral of 0 to infinity f of u e power minus su du can be written as L of f of t. So substituting in this equation, so L of f of t minus, so e power minus st L of f of t, it is in plus, so we can bring it as left hand side, it becomes negative. So L of f of t minus e power minus st L of f of t equal to integral of 0 to t f of t e power minus st into dt. So from that equation we can write this L of f of t 1 minus e power minus st. So this equation having L of f of t in both terms, we can take it as outside. So remaining terms 1 minus e power minus st equal to integral of 0 to t f of t e power minus st into dt. So here the 1 minus e power minus st, bring it to the right hand side, it becomes denominator, it will be in denominator. So L of f of t can be written as integral of 0 to t f of t e power minus st divided by 1 minus e power minus st. Okay, thank you.